Hi everybody, welcome back. This is the Building and Analyzing Polyatomic Ions lab walkthrough. The objective of this lab is to build models of compounds with polyatomic ions, name them, and analyze their formulas. So like always, we have a section with background information. This section is full of very useful information regarding this lab. So your first step is to use Table E to find the names of these polyatomic ions, and then to find the formulas of these polyatomic ions. So table E is going to be your best friend for this topic. Once you do that, we're going to build compounds with polyatomic ions. So at your station, you should see a bin full of little pieces. Your first step should be take all those pieces out and lay them on the table. And we're going to build neutral compounds for each of the ions that we have here, each of the pairs. So again, a neutral compound is when the height of the positive stuff equals the height of the negative stuff. Let's work through an example. So we want to make a compound with copper 1 and phosphate. So our job should be to find the copper 1 pieces. That is this, they'll have the name and the charge on them. So we're going to find our copper 1 pieces. We'll describe all of them. And we're going to find our phosphate pieces, which are these. So let's push all the other ones to the side. Now that we know we have just these, our goal is to create a formula with them. So what we could do this in two ways. Just build it with compounds, or we could look at the formula first. So remember, we want positive stuff and negative stuff to equal each other. So phosphate has a -3 charge. So this whole thing, PO4, that entire compound has a -3 charge. So this is what we call a polyatomic ion. Poly meaning many, atomic meaning we have many atoms forming that ion. So together, this phosphate piece, you cannot break it apart. All of these pieces are covalently bonded together, has a -3 charge. Now again, we want our compounds to be neutral, so this can't exist on its own. It needs to be attached to something. And that is where copper 1 comes into place. And so our copper 1 has a +1 charge, just like that. So if we're building our copper and our copper 1 with our phosphate, if we have our copper 1, which is positive, and our phosphate, which is negative, they will ionically bond together. So you have this ionic bond between this and that, and then inside your polyatomic ion, you have those covalent bonds. Now, obviously, we cannot use one copper for one phosphate because we want both sides to be the same thing. So what we're going to have to do is add another copper. Now you can stick these two together. Again, now we have 2 coppers and 1 phosphate. That's not enough either. So we'll take that third copper and stick it on. So now, both our positive side and our negative side are the same height, and that's the goal for all of the compounds. So we have 3 copper 1s, and we have 1 phosphate in our compound. So for this example, which is right here, you have 3 cations, so 3 positive things, with a total +3 charge. We have one of those anions, the negative thing, that has a -3 charge. Our overall charge is 0. And so our formula is this. We have 3 Cus, so there is that part. We have 1 PO4, so that is that part. And then we'll name it. And on your pieces, or on here, it's literally just the first thing and the name of the polyatomic ion. So if we go back to here, we can use our crisscross method. So we have the 1, which will bring down, and we have the 3, which will bring down. So we have Cu3, 3 of those copper 1s. And then whenever you have a polyatomic ion, you have that parentheses. Remember, this doesn't come apart. You have to keep it the same. We have 1 of those. Again, you don't need to write the 1. You can leave it as Cu3, PO4. Your job will then be to use all the other pieces to build the other compound. You will have to break them apart in order to build new ones because some of these pieces are repeated. Then you have 3 questions to answer at the end. When you are done, unmagnetize your pieces, take them all apart, put them back in the bin so it looks like that. And that is the lab for this week.